You might have noticed that Coulomb's law looks almost identical to the formula for universal gravitation. So the Fg equals big G m1 m2 r squared. And look at the electrical chart force. Uh, K Q1 Q2 r squared. So you notice we multiply a constant by two values and then divide by the distance between them. Okay, the big difference is look at those constants. Big G is 6.67 times 10 to the negative 11, so a very small number. And K is 8.9 times 10 to the 9, a very big number. So that's a big difference between the two. Okay, because of this difference, gravitational forces are known as very weak, while electrostatic are very strong. And that might seem a little counterintuitive if you think about, well, I can see things falling to the ground all the time, whereas I don't really see electric charges. Think about how gravity seems so strong, keeping you stuck on the earth right now. When you used a rubbed rod to attract bits of paper and lift them up, you're using a wimpy little charged rods to beat the entire gravitational force of the whole planet of Earth pulling those pieces of papers. Okay? Another important difference is that gravity can only cause attraction, but electrostatic force can either attract or repel. So really that electrostatic force is much stronger than the gravitational force. I can just use a charged rod and I can move pieces of paper, I can pick them up. So that means that force is stronger than gravity. That force from that tiny rod is stronger than the force from the entire Earth pulling those pieces of paper down. So take some thinking, but the big difference is that the electric force is much stronger than the gravitational force.